Time what?
Gravity.
The force acting. What force?
Gravity.
Equal to what? I alpha. Do you know the moment of inertia of the rod with respect to the end?
Yes.
What is the formula?
Now 2/3.
ml squared over 3. Time what? Let's say that we are looking for alpha first, which is A over R if we want to find A at a certain distance. But now we want to find alpha, initial angular acceleration. This, the same M, is not different M, same M. Is the mass of the rod. So what will be alpha? At the beginning, what will be alpha? 3 over 2 G over what? Over what? Over L. So alpha O is 3/2 of G over L. If I want to find the linear acceleration at the end of the rod, what will be? Alpha times what? What is the linear acceleration equal to? Alpha R. If I want at the end of the rod, what will be R? At the end of the rod, I want to find at this point what is A. What will be? L. So will be 3/2 of G over L times what? Times what? This is alpha. Times L, what will happen? So how much will be my acceleration with respect to the gravity? Greater or less? Greater. So what will happen if I put any object here? Which object will move faster or will have more acceleration at the beginning? This object or the end of the rod? Which one will have more acceleration? According to that equation, the acceleration at the end is 3/2 G. If this is falling, what will be the acceleration of this guy? G, the acceleration. So the acceleration will be G, and this at the end is 3/2 G. Which one is accelerating faster? The end of the rod. Can you see? There will be a point where these can go together because the acceleration is equal to G. Can be a point, we can find that point. So saying that the linear acceleration is G, if I said that the linear acceleration is G, which is 3/2 of G, and now I put here X, I can find when the two objects can go together. Is that correct? Because I am putting that both objects are moving with G. I mean, the rod at one point will move with G. So I can find this. At what point will be 2/3 of G? I mean 2/3 of what? 2/3 of, where do we have? 2/3 of L, but the G and G cancels out. So I have 3/2 of G. Wait a minute. I have A, which is this. Okay, sorry. A is 3/2 of G over L times X. If I put gravity equal 3/2 gravity over Lx, I will get that will be at 2/3 of L. Is that correct? So at 2/3 of L, these two objects, what is 2/3? 2/3 in a ruler. What will be 2/3? 66. So if I put that 66, what is 66 here? Here. So if I put at 66 this object, probable they will go for the most part together. So we can see. Can you see? So if I put at the end, you can see that the ruler is faster. If I put here, but if I put the minimum point that this will move together, is at 0.66. So this is 60, this is 6. So you can see that they are moving pretty much together with the same acceleration. So this is the motion of the rod. Any question with the rod? How to get the acceleration? So same thing. Gravity, the length, the distance, gravity, and this is the initial. What will happen, or what will be the acceleration at this point? We go with the same formula. What will be the formula? We go, by definition, what will be the torque? B. What will be the torque? So 3/2. What will be the torque now? In this situation, what will be the torque by the definition? What is R? Distance from the axis of rotation to the point of application of the force. That changed?
No.
What force is acting? It's changing. I mean, suddenly came another force from another planet to here. It's the same force, right?
Yeah,
mg. Time, by definition, what is the next things in the torque? Sine of what angle? The angle between the force and the R. This is R, and this is this. What angle will be 30 degrees or 60? By the definition. Can you see that it's 60 degrees the angle between R and F? If you put tail with tail, you can see that R is in this direction and FG is in this direction. This is the angle. And what was the angle given? This was the angle given. So you just don't go by the angles they give, because maybe the angles is not the correct one. You have to figure it out. The definition is very clear. Angle between R and F. Not between the ceiling and R. That's not the angle. It's between R and F. So that will be cosine of what? Cosine of, so it's either cosine of 30 or sine of 60. Equal to what? My bad. With respect to the end. And I am looking for alpha. And that will be alpha. You just look for alpha. So this L cancel out with this L, this M cancel out with this M, and we get that alpha is equal to 3/2 of G sine theta over L. Not theta, sorry. Sine 60. Because it's not theta. 90 minus theta. Get the study guide. And we finish with the rod. There will be an additional question, which is, I can ask later, I will ask, find the kinetic energy of the rod or find the angular velocity of the rod. But for that, we will study in the next class energy. Oh, the study guide. Bye-bye.